Common Sense AI. Building common sense into AI is often called the holy grail of artificial intelligence. While a model like Gemini can explain quantum physics or write a sonnet in seconds, it often struggles with the basic logic a toddler possesses, like knowing that if you flip a water glass upside down, the floor is going to get wet. Teaching an AI common sense involves moving beyond simple pattern matching and into world modeling. Here is the current blueprint for how researchers are trying to bridge that gap. 1. Knowledge graphs and symbolic reasoning. The earliest attempts at common sense involved manually hand-coding every rule of the world. Projects like Psych or ConceptNet built massive databases of assertions. How it works: you create a web of nodes, objects, and edges, relationships. Example: toaster is used for heating bread. The problem: the world is too complex to write down every rule. This is known as the knowledge acquisition bottleneck. 2. Statistical learning, the LLM path. Modern models, like the one you're talking to, learn a version of common sense through sheer scale. By reading billions of pages of text, the model learns that fire is usually associated with hot and danger. The strength: it captures linguistic common sense, how people talk about the world. The weakness: it lacks physical grounding. An AI might know that heavy objects fall, but it doesn't actually understand gravity because it has never felt weight or seen an object drop. 3. Embodied AI, physical grounding. Many researchers argue that you cannot have common sense without a body. This approach involves training AI in physics simulators or real-world robotics, learning by doing. By interacting with a virtual environment, the AI learns intuitive physics. Key concepts: object permanence. Knowing an object still exists even if it's behind a curtain. Affordances. Understanding that a chair is for sitting, but a cactus is not. 4. Neurosymbolic AI, the hybrid model. The most promising path in 2026 is neurosymbolic AI. This combines the gut instinct, pattern recognition, of neural networks with the logical rules of symbolic AI. Neural component handles messy data like images and natural language. Symbolic component enforces hard logical constraints. For example, two objects cannot occupy the same space at the same time. 5. System 1 versus System 2 thinking. Borrowing from psychology, Daniel Kahneman, developers are trying to give AI 2 gears. System 1 fast, immediate intuitive responses, current LLMs. System 2 slow, deliberative logical reasoning where the AI thinks before it speaks to verify if its output matches common sense. Summary table: common sense approaches. Approach, method. Pros, cons: symbolic, hard-coded rules. Transparent, logical. Impossible to scale. Connectionist, large-scale training, flexible, creative. Hallucinates facts, embodied. Physical interaction, real-world grounding, computationally expensive. Neurosymbolic, hybrid systems. Best of both worlds. Extremely complex to build. Building common sense isn't just about more data. It's about teaching the AI why things happen, rather than just what word comes next. Do you know that any private information you put into a cloud AI is used to train that AI? A private AI running on your own hardware is the best way to keep your private data private. I can help you set up a private AI on almost any PC or server. Contact me for a free consultation. If you get value from these blogs, please consider joining my Patreon as a member at the $2, $4, or $8 level. There are more than 400 previous blogs on my Patreon page, https://www.patreon.com/Steve Hovland.